Hello everyone, here I am Badal Sagar and welcome to the part number 10 of our present discussion, chapter number 2. So, in this part, we seen something new apart from the what till we seen in the physics. Today we discuss regarding the dielectrics. Electrics word may you come across might be heard anywhere in this our present discussion of the chapter number 1, 2 and 3 and like that. But here one word is the dielectrics. Maybe polar molecules or some of the words are there, but as a polarization is also there. So let us start this our new and exclusive topic for the chapter number 2. This is the intermediate part. This is a topic which is an intermediate topic between electrostatic potential and capacitors. This is our title of the chapter. This is an intermediate topic. It is a must required to understand what we learned and what we will learn in a capacitor. Okay, so this is very important part for you. 2.10 electrics and polarization. Here I am showing one figure. In this figure it is a very high level. After the understanding of the whole topic, then only you can able to understand what I am trying to showing you. But still, just for your information, I am putting this. No any kind of required for the understand and draw. No, just a showing of dielectrics material looks like this. It is what kind of dielectric material it can be in a physics. I will introduce now. It is start. After the ending of whole topic, you can come back on this first slide and see this figure. You will be able to understand what is representing in this figure. Then it is called you are completely thoroughly goes to the 10th topic or 10th part of this video. Okay, so you have to come back with this video. Okay, let's start. Dielectrics are non-conducting substance. What is the mean of conducting substance? Conducting substance in this conducting and non-conducting in a scenario with the help of electricity. They are the conduct electricity. They are the known as conductor, and here non-conductors. So the non-conducting materials. Why it is a non-conducting materials? Because they don't have any free charge. Those like metals having a free charge, free electrons are in the outer orbits. They are free to move, so they are responsible for the conductivity of electricity. That we already seen as a 11th standard student also. But those are the not conducting in nature are used for the dielectric materials. So this is very important MCQ for you. In contact to the conductor, they have a no negligible number of charge carrier. I can say there is no charge carrier. Charge carrier means electrons are responsible for the conductors. They don't have free charge carriers. Okay, carrier means they are carry the information, carry the electrons like this. They don't have charge carriers. They have electrons, but they are bound to the nucleus, each and every nucleus or atoms. They don't have free electron C. Okay, so till that in the first slide, what you understand? Non-conducting materials, some of the non-conducting materials are very good dielectrics. What is dielectrics? I will explain you. Di, it has two, because the two thing which is comes, and electrics. So the two electrics, what is the mean at the end you will understand. Okay, let's start with this conductor. Now once we understand what conductors do, then we can see what the polarizations or the dielectric material can do. When a conductor is placed in external electric field, let me see. Here this is a gray color. It is a conductor, and conductor has a number of free electrons. When we apply the electric field in the specific direction as shown arrow, so this is the outward, so it is a positive. So always attractions of the negative, or you can able to see that is the electric field goes like this. E0 is the applied from the externally. This is a going electrons electric field, so they are the always attract to positive charge, so that in a conductors there's some of the positive charge on the rightmost and some of the negative charge on the leftmost. So these separations of charge within a conductor, this is very important. The separations of charges within a conductors also generate its own electric field, and that is represented by the EI in. It means E internal. Because of the separations of charge, it has a electric field transformations. This E internal is exactly cancel the when till what it can be separate. It is till it can be separate the charges, so it can generate the E internal is equivalent to the E external and in opposite directions. So if we sum the electric field of external and internal, it will be going to be zero. This kind of property has conductor only, because we seen in earlier topic only, ninth part, the conductor as inside the conductor electric field zero. Why? Because of this reason. This is the exact reason of these things. The separations of charge is separate till that separate charges generate the internal field is completely opposed the external field which is present on it. Is it okay? Let's start next way of representation. The electric field due to the induced charge is opposed external field within the conductor. This happens until the static situations, the two fields are cancelling each other's. The net electrostatic field is going to be zero. Very important. This is what about the conductors, and our topic is non-conductor. It means dielectrics. So let's see the conductor scenario, and then we go for the dielectrics. This is I am showing the conductors what we seen, and this is what we have, dielectric material, I can say non-conducting material. So from just seeing the figure also we can get an idea the field which is cancelling exactly in the conductors. In the dielectrics, or I can say non-conducting material, this is not cancelling each other's exactly. They are cancelling each other, but resultant something left. You can see the magnitude of arrow. The length of the arrow is also show the magnitude, as we are aware about the 11th class vector scenario. Is it? So you can able to see that is E0 is dominating, so it's still polarizing these things. And once it is polarized the molecules, then it has a surface as gets the charge. The one surface is the negatized, the one surface is positized, as you can able to see. Let's start what the theoretical it is. In dielectric, this free movement of charge is not possible. In dielectrics, they are the non-conducting materials, so they don't have a free electrons. So there is a no free to move the charge are possible. It turn out to the external field we must require to induce dipole moment by stretching and reorienting molecules of the dielectrics. What is it? I'm trying to explain these things. We have a dielectric material. It means a non-conducting material. They don't have free electrons, but they have electrons and protons and all that. Okay. So when we apply the electric field, according the electric field, it has get separations or it adjusts in a such a way, adjusts and reorient its molecules. The sum of the surfaces of the conducting material is gets depositized. It means it's positive charge transfer, as you can see, and it is sum of the it going to be negatized. This is also generate the electric field as we seen in the earlier part also. But this electric field is not sufficient because the charge is not much in a non-conductors. So they are not cancelling each other exactly. But still the E0 is still dominating. So it's still separating this charge, reorienting the charge, and then disturbing the charge within the surface or within the conductors or within the non-conducting material. Obviously. So still they are modified inside the molecules. So this is the very crucial thing. The dominating of external field is very important thing. and this dominating external field is resulting the dielectric in nature. Polarizations of the molecules is in the collective effect. Now I'm going in the third part. The collective effect of all molecules dipole moment is net charge on surface of the dielectric, which produce a field which that oppose the external field. You can able to see the what charges are separating, they are also produce the electric field which is opposing the electric field which is present by the externally. It is this direction, but internally this direction. However, the opposite field so induced does not exactly cancelling each other, so it reduces the what externally it is present, but still it is externally is present. But okay, so you have idea, external in dielectrics external magnetic field is still dominating. What it cause? Let us see. To understand the effect, we need to look after the charge distributions of the dielectrics and the molecular level. Some of the molecule I am taking, for example, you can able to see the H2CO2 and HCl and H2SO4. Why this four only? You can able to understand after the discussed. These two are the linear molecule you can able to see, and they are also tagged as non-polar molecules. And here the one word is the polar molecules. Why? Let me explain. Non-polar molecules, the center of positive charge and negative charge which is coincide. Here we have two H2. If it is one of it is positive and one of is negative, they are the exactly in similar directions, so they are cancelling each other its effect. The molecule then has no permanent dipole moment. Okay, the molecules of non-polar molecules are oxygen, H2, O2. Some of them are linear molecules which are cancelling each other its moment, because see in H and if you have a tank of hydrogen H2, then each H2 has another H2's near equal. They are cancelling each other dipole moment because they are linear molecules, so which are there because of their symmetry have no dipole moment. But in this case, it below 2 HCl and H2O, what happen? A polar molecule, one is which the center of the negative charge, center of the negative, see HCl is like a H plus Cl minus, but the Cl minus is very high. It means big in the compared to the 17 number, and hydrogen is only one number. So charge separated by the each other. So even when there is no external field, still they have a molecule have permanent dipole moment. And ionic molecules such as, so these are the molecules are HCl, H2O. See, this is also depending on the bonding. HCl is always make a bond between them. It's a ionic bond. If it is ionic bond, then they have a positive and negative charge on it. So this will be always produce a dipole moment. But the H2 and CO2, they are the covalent bonds. So they covalent bonds are never produce the dipole moment because they are not sharing the electrons. If they are not sharing electrons, so electrically it is neutral molecules. If those are the molecules which is electrically neutral, they don't have any kind of polars. They don't have any kind of polarity. It means separation, dipole moment. So they are the non-polar molecules. And those are having ionic bond as more or less they are the polar molecules. So one thing you have to add in your mind, two kind of molecules we have, which is polar and non-polar, and that idea is shown in this slide. So here we have a non-polar molecules. Non-polar molecules, it means their initial state, if we are not applying electric field is zero. See, your eyes should be here. Okay, in non-polar molecules, the positive and negative charge, they are coincide each other. It means they don't have any separation, otherwise they are the polarized. But if we say non-polar molecule, if we apply electric field, it means not zero, we have finite electric field, then they are the separate the positive and negative charge according the electric field direction. So if we are applying from this to this direction, then these are the sides. It means the left side of your phone, they are separated by the negative charge, attract towards negative charge, and right side of your screen will be the positive charge. You can able to see that each and every these molecules is going to be likewise, is this molecule likewise, this molecule. So everyone has same nature, positive positive positive, negative negative negative. Okay, so this is non-polar molecule does develop a induced dipole moment. Why? Because now we have a separate charges, and separate charges always generate the dipole moment. So you can see that small dipoles are now onwards we have inside the molecules. So the dielectric is said polarized by external field. The dielectric materials are the polarized. We can polarize. It means polarization means what? Let me clear. Polarization means separation of charge. You are generating separation of charge? Yes. So I can say I am doing the, I have a, first of all I have a non-conducting material. Among the non-conducting material I have a two category, polar and non-polars. So I am taking first non-polar categories material and I am trying to apply the electric field on it. Once I am applying the electric field on it, they are the polarized. What is called polarized? Polarized means separations of charge in a particular directions. So here we have our stage. Okay, till that what we discussed, I am revised. We consider only simple situations when induced dipole moment in the directions of field. It has a dipole moment also in a particular directions which is opposite in the directions of the electric field. Direction of the field is proportional to the field strength. What is the directions of the dipole moment? It's always negative charge to the positive charge. So this is the directions of electric field we define, and the negative to the positive dipole moment also in the same directions. So dipole moment and applied electric field will be the same in direction. But the generated dipole moment, how much dipole moment it can generate? It is equivalent to the how much electric field you applied. See, one conducting material I have, I am applying the electric field small, then will be small separation will be happen, small separation generate the small dipole moment, so that it is a directly proportional to the electric field. So how much dipole moment will generate inside the dielectric material will depends on the electric field what you applied, how much strengthful electric field you applied. Field strength depends on proportional to the field strength. The induced dipole moment of the different molecules are, so different molecules has different dipole moments. Each and every has one dipole, and one dipole has one dipole moment. So the overall the dipole moment of the material will be the adding of each others, its addition of each others. So add up, it's given the net dipole moment of the dielectrics in the presence of electric field. Is it okay for these non-polar molecules? I am going for the polar molecules. This is what the polar molecules. Your eyes should be here. See, in earlier it was, what is it? I am showing that again. It is a coincided. They are the in the bound state. And in a polar molecules, they already separate, but they are random in nature. See, so that each, so separation already there. Your eyes should be here. The separations is already there. They have already dipole moments. Polar molecules is already have dipole moments. What is the definition itself is like a polar and non-polar. Those molecule have permanent dipole moment. It has, they are the polar. Or I can say in a reverse way, those are the polar molecules has always dipole moment because they're already separated charges. So, but it is in the random. You can see one is here and there and here and then, but once we apply the electric field, they are the orient each others in a particular directions. So you can see now onwards left on the left side, and right it be the right side. It means positive on the right side, negative on the left side. So once it is like this, like these situations, then it start to generate the permanent dipole moment. Outside it is filled. Now it is what it is. Dielectric which is polar also developed a net dipole moment in external field, because if we are not applying external field, they have a random in nature. If we apply the electric field, they have a particular directions, then we get a result. But for the different reason, in absence of any electric field, the dipole per different permanent dipoles are oriented randomly due to the normal aggregation. So they have a total dipole moment is 0 if we absence of electric field, but if it is presence of electric field, it has dipole moment. Okay, so when external field is applied, the individual dipole moments tends to align themselves, and the sum over all the molecules, they have now net dipole moment. It is a very easy to understand. I am just stretching this topic to extend up to what level you understand. For example, the dielectric is polarized. Now I have dielectric material in and I am going to polarize. To extend the polarization depends on the relative strength of the two mutual opposite factor, which is one is, so this polarization is depends on in a polar molecules is depends on the dipole potential energy. This is a beyond your class, but it depends on for your MCQ point of view. Please mark this number. Please mark this word dipole potential energy, and the field strength align themselves to dipole with the field of also thermal energy. These two things are affecting in a polar molecules, tending to disturb the alignment. I can explain these two words also, but this is going to be beyond your level. So skip this. Yes, just you have to remember these two things which is affecting the polarizations of the polar molecules. Whatever the polar or non-polar you have, the dielectric material has net dipole moment in the presence of electric field. I can conclude the whole what we discussed earlier in this 21 minute is all the dielectric material, whether they are the polar or non-polar, they have a net dipole moment in the presence of external field. If external field is not there, they are not polarized. Okay, the dipole moment per unit volume, the dipole moment per particular volume elements, they are known as polarization, and this is denoted as a P for the linear isotropic electron, and that polarization P is equal to chi time of E, where P is the polarization, chi is the electric susceptibility, this is a new for you, and where E is your electric field. The polarization is directly proportional to the electric field. That is clear in earlier discussions also. But constant, now proportionality sign, if you remove P proportional E, if you remove the proportionality sign, you have to put the one constant. That constant is electric susceptibility. Electric susceptibility, it means how much susceptible our object or our material what you taken. So electric susceptibility is constant for the every materials, just like a constant for the conductivity, resistivity. These are the susceptibility is one of the constant which are related to the polarizations of the particle, and these are the relating to the non-conducting material. They have also in for the non-conducting conducting material, but these are not important. It is only importance in the non-conducting material. This is named as electric susceptibility, where chi E is the constant characteristic of the dielectric materials. Is it? The question is now, how does the polarizations dielectric modify the original electric field inside it? That how it modified? Let us consider a simplified rectangular dielectric slab. So this is what the dielectric slab I am taking, and I am applying the electric field in the particular directions. According to the applied electric field directions, they inside the polar molecules are aligning particularly in this directions. So according this direction I am applying, to this side all molecules are the negative, and this side rightmost are the all are positive. So you can able to see now. Please see. Let us consider the rectangular slab. Yes, consider it. Uniform electric field we applied parallel to the slab. The field is caused uniform polarization. Yes, they are the generating polarization inside the slab. You can able to see. This is our status now. As shown in figure, the positive end of dipole is unneutralized at the right surface. Before the going in this, I have to explain these things so you can able to understand that. Now see, your eyes should be here, the first negative charge, left it, see your eyes at the positive charge which is next. This positive and this negative will be cancelling each other consecutive. This positive and this negative will be cancelling each other. This positive and negative is the cancelling each other. The resultant is this is negative, and this is the resulting in the positive at the end, and resulting which is negative on this end. So this side which will be all are the negative charges are leftmost side of the surface, and the positive sign which are left to cancel by the each other inside the surface, inside the conducting material. So still this surface which is end up with the positive charge, and this surface is the end up with the negative charge. Now let us understand. As shown in figure, the positive end of the dipoles are remain unneutralized because inside they all are neutralized, cancelling each other. A right surface of the, this is a right surface of the which is positive, and negative ends are the left surface. The unbalancing of this is resulting dipole, which is this is a separation of positive charge and negative charge. They have now own dipole moment in the directions of electric field, or I can say negative to the positive direction. Thus the polarizations of the dielectric is equivalent to two charged surfaces. So ultimately the polarization we are talking till that inside the material, it's only due to the surface charges. So earlier also I showed one figure, not the first one, in the in between I am showing the surface charges. One of the side is negative, one of the side is positive, because the inside all are cancelling each other. The resultant, this is a negative charge surface density which is minus sigma p, and this is a positive surface charge, this minus sigma p. So here volume charge density will be not considering, surface charge is important. So there are only two surface charges, only two charge surfaces which induced surface charge density sigma p and minus sigma p. Clearly the field produced by the surface charge opposing to the electric field, the total field in a dielectric is thereby reduces by this field which is generating inside the non-conducting material. We should note that the surface charge density, whether it is plus or minus sigma p, arises from the bound. It means no free charges in the dielectrics. This is all about required in this dielectric material. Okay, this is about dielectrics. Dielectric material, they are the non-conducting material. Second, and they are the polarized in the presence of electric field. They have a two kind of polar and non-polar molecules. Okay, then how much time it polarizes is proportional to the how much electric field you applied, P proportional E. Their proportionality sign is replaced by the susceptibility chi E. Susceptibility is a constant for the every material. So this is a one kind of constant. At the end we take one rectangular bar and we applied in the electric field, they are polarized. The every molecules are polarized, but the within a apart from the surface molecules, the all inside molecules are cancelling each other dipole moment. But the resulting one of the side of the surface will be the negative and one of the side will be the positive according the electric field directions of the externally. And the resulting the surface of the negative and positive, this produce the electric dipole moment of the non-conducting material, which is known as dielectric. And what is dielectric? Let me explain. Both are side electrified. Die, you are separating two charges, so it is die, and electrified because you at the end you generate electric field inside the material. Die conducting non-conducting material has now electrified by external electric field. This is the what is the mean why this topic is inside this chapter, because these materials are used in capacitor. This is very important. Thank you for the till next time we come back with the capacitor scenario, and the capacitor we need this dielectric understanding. So that's why this topic in this chapter. Thank you very much. Yes, I want to request you one thing. You may have to what is called feedback. If you do if you like my videos, then do the comments, do the like, so I can understand yes you are seeing the whole video, and then you are like that my video way on which I am representing to you. Please give feedback. Okay.